When the permafrost thaws, the organic matter in the permafrost thaws as well and begins to decay. The microorganisms start to eat it. If there's no oxygen, the microorganisms make methane. If there's oxygen, the microorganisms make carbon dioxide. Permafrost. Right here. Frozen dirt.
Permafrost seems to be decaying, and there is the threat that at some point in the not too distant future that a very large amount of the carbon that is stored in the permafrost and frozen soils could be released into carbon cycling.
Permafrost, frozen ground that's so cold it stays frozen even during the summer.
Permafrost is any earth material under ground surface which at or below 0 degrees Celsius for 2 or more consecutive years.
Now in the Arctic, we know that climate is being impacted faster than any of the models have predicted. It's also being impacted to a larger extent than the models have predicted. Some days we can fly through and see methane concentrations and even CO2 concentrations that one might associate with flying near a large oil or natural gas production facility or flying through the middle of a large city. They're elevated that much. But when you look down at the surface, all you see is pristine wilderness, typically wetlands and rivers with sporadic forests and grasslands. This kind of occurrence out in the middle of nowhere, far, far distance from any large human habitation areas is quite remarkable to me. There is a high potential for large amounts of carbon to be released from the Arctic ecosystems. How much of this carbon that's currently stored in the frozen permafrost soils, peatlands, and boreal forests is actually susceptible to being mobilized is key. Also, how fast this carbon might be released. Is it released over 100 or 150 years, similar to the perturbation pulse that we have from the burning of fossil fuels? Or is it going to be something that happens over a few decades, a few tens of years, in which case the perturbation would be significantly larger?
We have at least theoretical control on emissions from human activities. And because of that, we feel like we can do something to change it if it will be necessary. In case of thawing permafrost, there is no way to control it or to stop it. It just will go by itself.
There is a reasonable probability that once this starts, the amount of greenhouse gases released could then be larger than, it can even dwarf the amount of greenhouse gases that humans are putting in the air now. And at that point, it's completely out of our control, and in the sense that even if the humans stopped emitting more greenhouse gases, the release of the trapped carbon material in the tundra just runs away. We don't know exactly what temperature this is going to occur, but as we go to warmer and warmer temperatures, 4, 5, 6 degrees centigrade, many scientists are feeling that this may really kick in. We cannot go there.
Dr. Anton Vax of Oxford University has published a new paper which sharpens the focus on when exactly the tipping point for permafrost melt might begin to manifest.
The message of your research for us is that somewhere around 1.5 degrees C above pre-industrial temperatures globally,
yes,
that is when we would see continuous permafrost areas begin to melt.
Yes. So we probably managed to put a finger on a threshold. When exactly the continuous permafrost starts to melt? So this what it says, that this is probably the tipping point, the 1.5 degree warming.
Since the late 1800s, the planet has warmed approximately 0.8 of a degree centigrade, more than halfway to Dr. Vax's critical tipping point, and climbing.
I think the most important thing to realize about permafrost is that it's not an all or nothing question. It's not an issue of if the permafrost thaw, if 30% of the permafrost thaws, then all of the permafrost region will release its carbon. If we can limit our emissions, our CO2 and greenhouse gas emissions, then the permafrost region will release less carbon to the atmosphere. So there's a curve. It's not an all or nothing question.